Hi, so in this short video, I would like to show you the birthday problem. The birthday problem is a really great example because, well, I don't know how nerdy you are, but this is a great party talker because if you were in a room in a party, let's say of 10 people, what is the probability or chance that there is at least one other shared birthday of those 10 people? So sometimes sometimes you get a room with twins in it, and that's always fun because we know for a fact that they share a birthday. But what's interesting is to see the probability that if you're in a room with a certain number of people, you could actually calculate the chance that someone else might have the same birthday as you. So let's take a look. So in just this simple example, I only put 10 people. And so what is the probability that there is at least one shared birthday? So right away, we do see that at least one, right, would mean that we would use the formula of 1 minus the probability of none, right? So let's write down what we know and some information. So at least one means at least one. That would mean we would use a formula of 1 minus the probability of none. Another thing we need to note is does we need to know whether we're using um, permutation or combination or neither, right? So does order matter? Right? Well, yeah, because birthdays matter. The order of birthdays matter, right? So yes, of course, right? So order matters. And then is it with or without replacement? Well, it's without replacement because one person cannot be born on two different days, right? So if order matters and it's without replacement, we know we're going to use a permutation formula somewhere in our formula. And you're like, whoa, we're using at least one and a permutation? Yes. And then we want to say, okay, and then we also have to see, well, how many ways can 10 birthdays occur, right? I mean, because there's how many days in a year, right? Let's just say it's not a leap year. We'll use a standard 365 days. How many 10 birthdays combinations can I have? Probably a lot, right? Okay, so these are the pieces that I need. Okay, so we use 365 days in the year. Let's write that down so we don't forget. We're not using leap year. Okay, so let me write the probability of at least one birthday that's shared will be equal to 1 minus the probability that no one shares a birthday, which is more likely, right? Okay, well, if no one shares a birthday and there's 10 people in the room, that means 10 of these people, 10 people don't share a birthday. Okay, so I know it feels like I'm writing a lot, but what I'm doing is I'm building up to the formula. I'm already like a third there, right? Because if 10 people don't share a birthday, that means the first person there won't have a same birthday, the second person won't have a birthday, and therefore, if that person's birthday is taken, that date isn't shared with anyone, and therefore I have 9 people, 8 people, right? And so therefore, it's going to be a permutation, right? And we have 365 days to choose from for birthdays, and 10 of those days are taken by the people at the party. So this means that we'll have 1 minus, and the probability that the 10 people do not share a birthday is the number of ways 10 people can't share a birthday out of the total number of ways um, uh, people share a birthday. 10 people have birthdays. I'm sorry. That's what I want to say. So if 10 people do not share a birthday, the probability that 10 people in a room don't share a birthday is the number of ways they can't share a birthday over the total number of ways that 10 people can have birthdays total, right? Okay, so 1 minus the number of ways that people can't share a birthday with 10 people would mean that out of 365 days, 10 of these days are taken from those people's birthday. And therefore, I would have 365 choices, but pick only 10 of those days. And again, order matters, right? And without replacement. That's really important, right? But if we just look at all the people having birthdays out of 10 people, out of 10 days of 365, well, whether they share or not, that means that first person would have 365 days to pick, and the next person says, well, it doesn't matter if we share or not. I could pick that same day, so I still have 365 days to pick from. And the second person, and the third, all the way up to how many people? 10 people. So if I just draw over here a little like spaces, what is that, 7, 8, 9, 10. This is the first person, right? And then you're like, when's your birthday? On the second person, they're going to pick one of those days. And they could share, who knows, right? And then 365, and then so on. Well, how many people at the party? There's 10 people. It's with repetition. So this would be 365 to the 10th power. And that just comes from this product simply from the multiplication rule, the standard multiplication rule from the beginning of the section. Okay, so if I put this in the calculator, right, if I have 1 minus, I'll put parentheses, math, prob, permutation, 10 people, 365 days, the choices, and then pick 10 of them, right? Get out of the cursor, divided by 365 to the 10th. Get out of the superscript and close the parenthesis and then enter. So here it would be about 0.1169 or 11.69%. So there is a 11.69% chance someone shares a birthday among 10 people. That's a pretty high percentage, right? So in general, the formula goes, let me do a fun color. So we could say in general, if you let n people at a party, then the probability of at least one shared birthday is equal to 1 minus 365 permutation n over 365 to the n. So that's the general birthday formula of at least one person, one other person shares a birthday with another person at a party. It's fun, and I encourage you to do it at your own parties. Nice fun talk conversation starter. Okay,